Good morning, everybody. I'm glad you could make it to this session. I'm Ashwin Bhosle, Associate Director, responsible for big data strategy, planning, and implementation at Verizon. My team manages the strategy across Verizon's business organizations for big data as well as advanced analytics. So you'll see from two very capable leaders in my team, Ashok Prasad, who is the manager over big data, and he leads a team of engineers as well as data scientists responsible for harnessing the power of big data. And you'll also hear from Shivinder Singh, who is the architect on the infrastructure side. Shivinder and his team manages the Hadoop platform, as well as other things in the Hadoop ecosystem, and they help lead the infrastructure side of big data. So you'll see collaboration between application team as well as infrastructure team. And there are other teams who participate in the big data community if you speak. But what this community has allowed us to do is take technology from its inception stage and actually start delivering business value, which means millions and millions of dollars to Verizon's bottom line. Right? You'll see use cases today of how Verizon uses big data to understand the customer, and there are several implications of that from a churn modeling perspective, from campaigns perspective, right? From operational efficiencies perspective, customer experience perspective. You'll see a lot of those good stories today. So we have taken Hadoop beyond the storage use case, the ETL use case, which was more 2013, 2014, and have taken it to drive real business value, impacting customer interaction, impacting operational excellence, and so on and so forth. So without further ado, I would like Ashok Prasad to tell us the story of big data at Verizon.
Thank you, Ashwin. Really appreciate it. I'm going to start with a quick overview about Verizon. Verizon actually doesn't need an introduction. All of you have heard about it. Most of you are probably using our services. We are the biggest, largest, and the most reliable 4G LTE network in the United States. And we are ranked number 16th on the Fortune 500. We are a very large company. And I'm going to put a lot of emphasis on the size of our customer base, because that is where we get the data from. We are over 108 million customers at this particular time and growing. We've got unsurpassed customer loyalty, profitability, and cost efficiency, which drives us, especially with our big data environment that we've created, to produce more analytics and value out of it. We are a dedicated corporate citizen. We are applying innovative technology to social issues. Many of them are focused on finding new ways about how our technology can help healthcare, education, and many other areas. We are an excellent place to work with. We are very innovative, very enterprising, and I mean it in every sense of it. You're going to see the best that came out in a very quick time with a big data implementation shortly. So let me talk a little about our evolution of the big data space. We started our journey in early 2013. We always had an excellent enterprise data warehouse. It was a very mature environment that we have had for a number of years. But that was just about the time that 4G LTE was being rolled out nationwide. And it was producing a lot more of network data that we could have handled in a traditional way. We were getting a lot of customers who were joining us, brand new customers and customers who were upgrading from 3G to 4G, who were producing more data, and we wanted a place to save all of that network information. It was just about that time that we started looking at big data technologies, Hadoop in particular, which basically offered a very low cost of ownership from a storage perspective. We also wanted to have a good idea, a good look about our entire customer base. Instead of doing analytics and running discoveries on a limited data set, we wanted to go ahead and do it on our entire customer base. That is what got us started thinking on the big data side. It was middle of 2013 when we started running some proof of concepts. And when we were running proof of concepts, we quickly agreed to a reference architecture that we implemented in Verizon Wireless, which was unified data architecture. I'm going to speak to you all about it in a little more detail in the next couple of slides. But late 2013, we already had a pilot that was on its way to production. And early 2014, we went with the first use case, which was in production in January. So you can think about the time that we took right from a POC stage to basically piloting it out and rolling it out over on a production environment. Rob talked about it in our keynote address today as well. We were very agile, and we had a lot of faith and trust in the technology that we were adopting. I'm going to quickly go over to a different view about our same evolution here in this case. As I mentioned to you before, we had a great enterprise data warehouse. It offered us reporting, analytic, predictive capability from a long time. What we needed was that we were getting a lot of structured, unstructured, traditional, and non-traditional data that we wanted to combine with the predictive analytics that we were already doing at the time. And a big data infrastructure greatly helped us. I'm going to go a little more detail about them as well. But one of the things that we were running into is as soon as you discover an insight, you had to put it and operationalize it. The time that you took to operationalize an insight was being reduced greatly. There wasn't a time that you could take, like months or weeks, or at many times days. You had to do it right there and then. And with the arrival of the big data live streaming technologies that we have greatly adopted, it was an even trigger. It is even more faster than we ever did it before. And we are able to greatly enhance the customer experience. I'm going to start talking about the components of big data that we have implemented within Verizon Wireless. As I mentioned it to you before, we had a great enterprise data warehouse. It had all your traditional structured data, your customer profiles, sales transactions, billing history. All of that traditional data always existed in the enterprise data warehouse. We were getting a lot of network-centric data. We were getting a lot of other traditional structured data, non-traditional structured data as well, that we wanted to save all of that information. And that is where we invested a lot into our Hadoop clusters that we have built on the Hortonworks distribution platform. We have got possibly one of the largest clusters in our industry verticals. It would not compare in size to some of the ones that you're going to see at Facebook's, Yahoo's, and the Googles, but at the scale that we have, it runs into multi-tens of petabytes that we have already implemented it here. And to combine all of that, you have data in the enterprise data warehouse, you have data in your Hadoop environment. You wanted a medium that you would be able to federate your queries across both the places to get the best out of it. That is where we decided to invest in a discovery platform. We did our due diligence and agreed on Teradata Aster as a discovery platform, which is able to federate queries not only from the enterprise data warehouse, but also your Hadoop clusters as well. What it did was to provide a lot of capabilities out of the box in terms of different functions, for example, statistical analysis, time series analysis, that we were greatly able to use it without writing a single line of code. It came out of the box. It had functionality that it would allow you to connect to EDW and Hadoop through high-speed connectors. And it always existed. I mean, we had a lot of information that stayed in our enterprise data warehouse that we were not able to use it. There was a lot of data that we had but could not load over onto the enterprise data warehouse just because it was so super expensive to do it. This was the infrastructure that provided us with the best of all. And that is where we went ahead and decided on the unified data architecture. It has now become an industry-leading world. But more than that, we were able to have our existing tools talk to our UDA environment. You had your analytical tools, your visualization tools. You had even BI and other reporting tools. Many of them were customized tools that were available before that continued to talk to our UDA environment and fetch the data as required. I'm going to show you the same UDA from a different perspective here. You could have the best of the technology in place. You could have data coming over it. But if you're not able to use that particular data, if you're not able to drive insights or drive analytics out of the data, if you're not able to operationalize that particular data for a return of investment, it is no good. And that is where we started talking to our user base. Even before we designed it, we knew that we could not restrict our user community into a certain constrained area. We invested a lot of time in defining rules of governance. I'm going to speak about that a little later, but we broadly divided the users into 3 categories. I call it an inverted pyramid. And if you look at it, if you see at the bottom of it, you're going to see a computer scientist. These are the guys who basically help the data to be loaded into the data lakes, all the ingests that are going to be coming through. You have support from your infrastructure teams to make sure that all of your infrastructure is in place and is in good health. Over on the middle, you've got your data scientists and business analysts who are working with the unified data architecture. These are the guys who are able to drive insights. These are the guys who are able to drive analytics out of it. And they are able to federate queries across the 3 important pillars of the unified data architecture that we have. Your discovery platform, your EDW, as well as your Hadoop environment as such. One of the things that we discovered early on, that you have a lot of business analysts who may be working in particular groups, who have got a lot of domain knowledge about the data they work with on a daily basis. That was something that we wanted to take it and include them in a collaborative way so that they can work not only with the ETL specialists, like the computer scientists, but also the data scientists who are working together to combine information through a cross-channel perspective. I will speak to you about it shortly. And on the top, you've got your business users. These are the ones who take the insights that are being generated out of your data scientists, business users, analysts, and put that and operationalize that. That was a true functionality, and if you were to look at it, you would see the smallest number of people who are going to be in the lowest tier, and as you go up over on the food chain, you're going to find more and more people who are consuming the analytics, the insights that are being generated out of your UDA environment. Very quickly, how do we use this particular data? And the most important answer here is we are a very large company. I mentioned to you that you got about 108 million customers, and they're growing every day. They have a lot of interactions with the company. They have a lot of touch points. And to be able to deliver a good customer experience, we wanted to understand how they are interacting with us. In the simplest of the example, you might have a customer who is looking over on your web channel, trying to look at a product or accessory for that matter, and thinks about it, but doesn't make a full decision at that particular time. He would go over to a retail store to feel it, to see how it looks, how it fits, and then possibly buy it at a retail channel. But more than that, that was something which is good, that he was looking for a brand new device. But there might be existing customers, and there are a lot of customers that we have who interact with us on a daily basis. These are the customers who are working with us. They're working through the web channel, the IVR channel, the telesales channel. These guys are working through eChat channel. We have got a lot of systems that are collecting information about each of that touch points. And we wanted to get all of that information into one central location so that you can run your analysis. And that is where our big data infrastructure was ready to receive it. This is where we started loading all our information from all the different channels that we work with our customers. It could be a kiosk, it could be a web, it could be eChat, it could be like an IVR call, a POS transaction, whatever it may be. We are able to collect all of that information and are able to run discoveries on that. And when you run discoveries, there's a good chance that you want to run a discovery at an aggregate level first to understand the customer behavior, and you can then zoom in over a specific customer if there is a requirement to do that. And what we realize is that when you're producing a time series analysis of the whole customer journey, you see the paths the customers are taking. They might have started from an intent that they wanted to buy a new device or an accessory, but they might have crossed across 3 or 4 channels before they bought it. They might have upgraded a device. They might have upgraded a line, added a line. I mean, those are some of the good things. But not everything in the world is good. There are cases where a customer might churn away. And to a telco, churn is a very important critical parameter that we want to control. And that is where you are able to easily look at the flow in aggregate and then zoom in to understand what may be the events that are triggering a customer to go ahead and churn. That is what a customer journey is all about. And we do it as part of the unified data architecture in a big data platform. I'm going to talk a little about the changing ways that we have on the customer journeys. We have always been able to look at the customer journey for a long time, even when the big data infrastructure did not exist, when Hadoop did not exist. The problem was that we have been able to look at it in a silo mode. You were able to look at 1 channel, 2 channels at best, or maybe a couple, and that was it. The volume of the data was so huge that you could not drive any smart analytics out of it, and you were not able to have the complete entire customer data set. You were working with sample data sets, which obviously doesn't give you a good picture of it. What we have evolved to is a customer-centric cross-channel analysis, where the primary objective has been to enhance the overall customer experience, irrespective of any channel that he may have contacted us with. This is where we are combining all of those channels together. This is where we are running all the analytics, insights, and then operationalizing it. The same cross-channel analytics has evolved with big data. And as I mentioned it to you before, we always had that facility available to us, but it was more at a single channel where you're looking at thousands of interactions per month. We went over to a multi-channel approach where you might have combined, say, web channel and IVR, and then combined that data set, but they were still millions at best. And with the advent and arrival of cross-channel for big data, you were able to look at the entire data set that was available to you here. This is all your 110 million customers with multiple touch points. You're able to analyze and evaluate the customer behavior and predict a customer journey as well. And it gave us a lot of successes. There were many outcomes, and I'm going to speak a little about some of the use cases. Improving our customer experience. You all know, for any retail company, a happy customer is the best customer. And that is what we want to have. But that may be an ideal. All 108 million customers may not be happy at all given times, and there might be some issues that we have to work with. So what we were realizing was there were customers who were going over to the web channel. They're trying to buy something, and for whatever reason, they added it to their shopping cart but did not complete the transaction. And they decided to pick up the phone and call up a customer care channel. What we implemented out of the learnings of our big data was that we implemented a shared shopping cart principle. As soon as you moved over to a different channel, that particular channel operator was able to pick your previous interactions that you had and was able to complete a transaction. One of the other use cases, and this was something like that we didn't know we had a problem, and that is what we call as a dark data. And these were centered around some policy inconsistencies across multiple channels. What you could do on a particular channel, you were not able to do on a different channel. And the best way to look at this is basically look at the entire data set and try to do a good forensic about where customers are dropping, and then evaluate that particular zone to find out more information. And here you're able to combine your non-traditional data sources as well. What I mean by that is that if you were to call a customer care rep at Verizon Wireless, The care rep always takes some notes and puts it as part of the call. It was saved, and it was saved for a long time. But they all existed in the enterprise data warehouse that did not offer us a capability to evaluate, analyze, and drive insights out of it. We were able to drive it, and we realized what the problem was. A root cause was identified, and we fixed it. That saved tens of millions of dollars for our company. One of the other use cases that I would like to highlight here was a data alert that we implemented. Just by the description of all the cross-channel touch points that I'm talking about, you would have already guessed that we know a lot about a customer. And when we know that a customer is coming in close to his data limits, we are able to send him a SMS text alert or something which basically says, Mr. Customer, you're 75% or whatever threshold the customer set up, and say that you're very close to your data limits. Would you like to upgrade at a discounted price or at a promotional price? Click yes or no. And when he clicks yes, he is able to go ahead and auto-provision on the background without any customer interaction here. So these are some of the things that we implemented which greatly enhanced the customer experience. The second thing that I wanted to talk about was the call-in rate reduction. With 108 million customers, there are a lot of calls that are generated over to our customer care centers. We love to talk to our customers, but it comes at a cost. So what we did was that we analyzed the repeat caller behavior. If a customer is calling in for the second time, third time, or the fourth time, you know that you have got a problem. Obviously, you were not able to address the customer requirements on the very first call. So what we did again was that we were able to collect all the information about all the customer touch points, combining it with traditional and non-traditional data sources like e-chat transcripts that a customer might have had, a call center transcripts that a customer care rep saved for that particular customer, and we were able to identify some of the deficiencies in the process, which when we improved and fixed, was able to lower the call-in rate reduction. The self-service conversion increase. Web channel is one of the best channels that every telco loves. It is the cheapest channel to operate. And we do have a .com site, and many at good times, like, again, a customer is going to abandon a shopping cart and then walk over to a retail store, walk over to, or maybe call a customer care rep, again, in this particular example. We are able to analyze the behavior of the abandoned shopping cart and the experience that the customer had, which was noted by our call care reps, that was documented, and identify root causes, which when we fixed, obviously led to a better customer experience, and it increased the self-service conversion process. Last but not the least, I'm going to talk to you about agent productivity increase. Again, e-chat, what we were seeing was that there were a lot of customers who were coming over to the e-chat channel, and all of a sudden they were going over to a care rep. They were calling our IVR. We had to analyze the behavior about why this was happening. There was a case where there might be some issues with the process or even with the flow. We were able to localize, identify, and fix it as part of our big data cross-channel analytics over the customer journeys, and we have been able to save tens of millions of dollars here. Last but not the least, I'm going to talk to you about the big data governance. You have heard in a lot of keynotes here, a lot of other sessions that our speakers have been talking about a data dump. That is something that we wanted to avoid at all costs. And as I mentioned to you before, we had a very good EDW where we had a very good governance model. What we did, we took the learnings out of that EDW experience, and at the time that we were setting the stage to work with the big data infrastructure, we knew that we could not do it alone, that we would have to work with different business units, different business groups, and have to collaborate together. So we set up standards right from day one. We set up the protocols, the program management, the metadata management, the data security and access control. All of that was decided, and an onboarding process was defined before the data lakes and those business groups were onboarded. So if you look at it, I lead the big data core team, which is a central nucleus of this entire flow. What we work with are infrastructure teams, app teams, your sysadmins, your enterprise data warehouse and BI reporting teams. We work very closely with them in getting the data over to our big data platform. And what we do is we also embed ourselves into the business units, to the business groups that are going to be using that particular data, going to be loading that particular data over here, like marketing teams, customer service teams, and we work together to make it happen. This is something, it cannot be done alone, and I'm going to emphasize it. You can set up the rules, but if it is not going to be enforced, or that if it is not going to be believed, it is going to be a moot point. And that is something that we did, and I'm really proud of it to say that we are a data lake. Even 2 hours after the journey started, we never became a data dump, and I would not allow that to happen. With that, I'm going to pass it over to my colleague, Shwinder Singh. He's going to come over and present the next set of slides.
Thank you, Ashok. That was excellent. So the other day, it so happened, I was driving through McDonald's drive-thru and ordered my favorite dollar menu meal and talking on my cell phone. I got a little reminiscent about my very first job, which so happened to be at McDonald's as a student. And at that moment, I had a moment of enlightenment. What I realized, I was holding 3 of the most important inventions which mankind had seen: a car, a dollar meal, and a cell phone running on the Verizon wireless network. So, can you hear me now? So, as different as they can get from each other, the common thread between them is that all of these have been very successful in their respective areas. And if you think of it, why most of us are able to drive a car today or have a meal for $1 is essentially the result of optimization of operations. If you take any business, it can be distinctly divided into 2 broad categories: research and development and operations. The optimization of operations essentially enables the mass adoption of any product or service. If Henry Ford invented the assembly line, that essentially made all of us drive a car. But keep in mind, the operational excellence has always come in after a gap of time since the inception of the technology. Assembly line came in many years after the first automotive was invented, and the McDonald's assembly line essentially came many, many years after the first hamburger was invented. The key bottom line over here is that if a person like me in the McDonald's kitchen can flip a burger which tastes the same across the globe, the concept over there is that you are removing a specialty and putting a generalist. Today, we are almost in the 3rd decade of IT. If the first 2 decades were essentially focused around creating computers, applications, softwares, getting the businesses ready to adopt it, today we are at a stage where we are looking at a very mass adoption, especially with big data coming into play. So for us, as an IT organization, the primary objectives are always to keep the lights on, focus on SLA, reduce the mean time to recovery, and make sure that IT is acting as a business enabler. And I'm very proud to say that, Verizon Wireless has been the only carrier till date which has been able to successfully manage an iPhone launch whenever it happens. So we support all the customer-facing, revenue-generating online assets for Verizon, both from an application and database perspective. And when you have such a robust ecosystem, all of a sudden a technology like Hadoop comes. What is the first reaction you get? Well, my systems are working great. Why do I even need it? We are not trained on it. You're putting an elephant over there. What if it runs berserk? What if it takes my production systems down? So those are some of the questions, which we had when we started on this journey. And if you take a look over here, this is a slide which many of you might be able to relate to, no matter the size of your business, big, small, or medium. So initially, back in 2004 and 5 time frame, we were essentially an Oracle shop. Around 2006 and 7, we adopted our first NoSQL technology. And by the way, NoSQL was not the buzzword at that time. At that point, until date, we adopted Sun Directory Server. We are the biggest implementation of it in the world, both from a velocity and a volume perspective. So every time you're logging on to VerizonWireless.com or any of our portals, you're essentially passing through this gate. So as time evolved, we had Iraq, ACFS, and in the last 2 years, we expanded on a big data footprint and included Hadoop and other associated big data technologies. Now, I do remember the days, a typical 3 a.m. call that would essentially consist of database going down, server going down, or disk crashing. And when Hadoop came to us, it took us a while to adjust to the mindset that if a few nodes in my cluster are down, I can still sleep. Even if few disks are bad, and those are bound to be happening because you have your server footprint is so huge. So that is the concept from the assembly line which is translating into IT operations now. Even if your resources, you have suffer a loss of asset, you have assets which can balance them out. And just like a McDonald's lunch hour, if your resources are crowded, you can have them concentrate on a single place, and once they are done, you can once the traffic is done, you can reallocate it to another place. So back about 2 years when we started on our Hadoop journey, we adopted the Hadoop 1.3 architecture, and as Ashok explained earlier, it was more of a ETL framework which we wanted to achieve. So we were at a stage where our systems had grown up so huge. I mean, if you think of it, 2006-7, we were close to 50 million, and today we are 108 million plus customers, and we are also serving 4G LTE data, in which the data set size itself is bigger. So there has, and the traditional databases, they were having challenges in scaling up. So at that point, we went with the 1.3 version, essentially to start storing the data, and starting running the queries, which were having a hard time to complete earlier, and show the business the output of what we were trying to achieve in a short duration of time. We do have a 2.x cluster, which we migrated from 1.3 to 2. Last year, late last year. The way I look at it, 2. has been a whole marketplace changer. And that is not just for the applications which are within Verizon. Yes, we are working on our applications to get them yarn ready and move to 2.x. But essentially, the 2 factors which are really we are most concentrating on is yarn and security. And security includes Kerberos, Ranger, and Knox. So even if we are ready and Hadoop is ready, some of our partner applications are still getting to that level. So in that sense, Hadoop is currently pushing the marketplace to get there sooner rather than later. And throughout this entire journey, it's not like you take a bulk forklift of the technology and put it on the business. No. All along, we have always tried to tailor the technologies based on our need. For example, we custom-tuned a lot of Nagios to fit according to our operational framework. And from a security perspective, we secured our Hive Server 2 with our custom LDAP interceptors, which could secure our beeline and JDBC connections. So what have some of the technology challenges which we have seen in the adoption of Hadoop? Essentially, I can broad them into 2 broad categories: hardware, software, and people-related challenges. From a hardware and the software perspective, Hadoop has been very innovative. It's totally up to us on how we can use and bring more smart use cases to monetize it. And from an operations perspective, we need to be focused on how we can improve system performance and accommodate growth with system usage. From a people perspective, the traditional RDBMSs have been the flag bearers of the IT revolution. If you talk to people about SQL is still the English of databases. If you talk to people, they still think in terms of tables, rows, columns, foreign key, primary key, so on and so forth. So at times it becomes somewhat of a challenge to unlearn some of those old skills and assimilate the new ones. And of course, there has to be a focus on system automation and process engineering, which you already have in your IT ecosystem. With that, I would like to end with a small story. Once upon a time, there was a table which lived in the kingdom of a database. And so, as it would, the kingdom was small. And the table was designed to store the data for every phone which every customer had. Over a period of time, the kingdom grew, and so did the table. When one fine day, it reached close to 6 terabytes. Does that number even seem big now? I don't think so, right? But remember RDBMS, that's quite a big number. And there were queries which would never complete over there. So at that point, we decided to move off this table to Hadoop. And at that point, we saw a reduction of the table size from 6 terabytes to close to 2 terabytes, and which is 3x replication included. And the queries which were not running earlier started working very well. So the point of the moral of the story is, yes, Hadoop is new, but it can be a very good fit for something which was already there, and you have the potential to move it to the new platform. In addition to the new use cases which you are using to build your, to enable your business on, like real streaming and cross-channel analytics, which are the new use cases. So the actual success lies in blending the two and building your IT ecosystem to scale on that. With that, I would like to thank you, all of you, and thank you for joining us here. We are open for questions. Sure. You want to take that? Global ID?
So it depends upon a use case, basically. So depending upon the use case, he would have to come up with a good common key there. So what we do is that we have a session ID associated to each one of those, and we gather all the session IDs, and at places where the session ID is not there, we create a session ID depending upon a date and a time of the interaction that we had with the customer, and then sessionize the whole customer flow based on a time series analysis. So that is how we do it. Yes, we do.
I mean, that's the most optimal running. I think we are out of time, so we can take the questions on the side.